The most used material in the world is concrete. More than steel, more than wood, and more than plastic. If there's one thing you can know about concrete, producing it uses a lot of energy and it has a big carbon footprint. We've heard a lot about climate change and greenhouse gas emissions in the news lately, so wherever we can reduce concrete's carbon footprint is good for us and good for our planet. In fact, the electricity bill of the largest concrete producing company in Mississauga is second only to the airport. Nobody wants to waste materials, nobody wants to waste resources. That's where my research comes in. I'm taking a look at concrete pavement deterioration. Let's say you design a concrete road that's meant to last for 40 years, 50 years, and in a couple of years it starts to fall apart. What would you say about that? Doesn't that sound like it's a big waste of time, money, materials, and greenhouse gas emissions? Well, that's exactly what's happening. My research is looking at these pavements that are failing early in their life cycle and the physical and chemical interactions. What we'd like to do is develop an accelerated test so that we could see ahead of time how a concrete will perform. Here's what we do. In a concrete mixer, we make some concrete. We pour our fresh concrete into molds. With a diamond-tipped saw, we cut a joint into our slabs, just like you'd see in a real concrete pavement. Now, as for these pavements that are deteriorating early in their life cycle, the damage generally starts at the joints. And this damage comes from de-icing salts that are put onto roads and from the harsh environment. We want to subject our samples to the same conditions as a real concrete road. So we expose our samples to salt, to wetting and drying using an oven, and to freezing and thawing using a freezer. We use different types of salts because different salts have different chemical reactions with concrete. The goal of my research is to record the damage that takes place in this concrete. We want to mimic the damage that happens in the field so that we're seeing the same kind of damage. And we want to develop an accelerated test so we can determine ahead of time if concrete will be suitable for use or if it will fall apart quickly, saving us time, money, materials, and greenhouse gas emissions by doing it right the first time. Thank you.